let's talk about and distinguish between accuracy and precision in measurement. And I think it's first important that we identify these words. So for something to be precise, it means that the values that we are measuring agree with each other. So let's say we measure something multiple times, and every time we measure it, we get a very similar answer. That's precise, right? Because it's all basically the same. Now, accurate, on the other hand, is when whatever we measure agrees with the true value, right? So you measure and you get a value that is very close to what's considered a true value. So let's think about like a baseball field. You talk about home plate to first base, right? It's supposed to be 90 feet, right? That's the true value. So if you take your yardstick out or your measuring tape and you go out to the baseball field and you measure and it's 89.98 feet, and you're like, yeah, that's pretty accurate because the true value is 90 and 89.98 is pretty close to 90. So that we would say is accurate. Okay, so that's the idea that we're going for here. Okay, so now to kind of show the difference between precise and accurate, let's think about a dartboard. So a dartboard, right, is circular, and then the inside we have the red bullseye. Now on each of these three, right, so we have 1, 2, 3. Each of these has 3 green dots, or just 3 dots, that show where the darts hit. So in number 1, all 3 dots representing the darts hit inside the bullseye. So this is precise because all 3 are in the same general area, but it's also accurate because the true value on a dartboard, right, the goal is the center. If you're just shooting, unless you're playing some random game, but it's accurate because the true value is right in the middle and that's where we hit, and it's precise because they are all grouped together. Now in number 2, you will see they are all grouped together up here in the upper right quadrant of the board, and therefore they are precise because all 3 have a similar value, but they are not accurate because they are not anywhere close to the middle. Right? The true value on a dartboard. So we would say these are precise because they're together, but not accurate. Now in number 3, you can see we've got one on the top, one on the left, and then one in the right, middle right. Okay, so those are not anywhere close to each other, so they are not precise, and they're not anywhere close to the middle, so they are also not accurate. Right, just to kind of give you a visual about these things. Now let's do one more example. A soda bottling company is checking the soda dispensing machine. Each bottle is to contain 20 ounces of soda, right? So this is our true value. 10 bottles are checked with the following measurements. All of these are in ounces. 18.9, 18.8, 19, 18.9, 18.7, 18.9, 19, 18.8, 18.8, 18.9. What do these values tell you about accuracy and precision? Now, if I'm buying a bottle of soda that it says 20 ounces, notice that all 10 of these, none of them are over 19 ounces. I would say these are not accurate, right? Because they're supposed to have 20 ounces. This is not 20 ounces. This is 19 ounces. But they are, right? This is a very precise machine. They're all very close, right? Right around 18.8, 18.9 is the majority of them with a 7 and a 19. They're very close in value, so they're precise, but because we want them to be 20, they're not accurate. And that's the big difference between precision and accuracy.